Welcome back, dear children. In the previous class, we learnt about two types of chemical reactions, combination reactions and decomposition reactions. Today, let us study the third type of reaction, that's displacement reaction. A chemical reaction in which a more active element replaces a less active element from its compound is called a displacement reaction. A more active element displaces a less active element from a compound. In such reactions, one constituent of the reactant molecule is replaced by another. The reaction can be represented as A plus BC gives AC plus B. Here, A displaces B from its compound BC because A is chemically more reactive than B. Here is an example. Zn plus CuSO4 gives ZnSO4 plus Cu. Zinc, being more reactive than copper, displaces copper from copper sulfate solution. The blue copper sulfate solution turns colorless due to the formation of zinc sulfate and a reddish brown copper is deposited on zinc. From this we understand that zinc is more reactive than copper. A metal more reactive than hydrogen displaces hydrogen gas from an acid. This also is a displacement reaction. For example, potassium displaces hydrogen from hydrochloric acid. The equation is 2K plus 2HCl gives 2KCl plus H2. Another example is calcium displaces hydrogen from sulfuric acid. Ca plus H2SO4 gives CaSO4 plus H2. Here is an activity to show that iron is more reactive than copper. An iron nail is placed in blue colored copper sulfate solution. After some time, a reddish brown coating is seen on the iron nail and the color of the solution changes gradually from blue to light green. This is because iron, which is more reactive compared to copper, goes into the solution while copper is deposited on the iron nail. We have the equation Fe plus CuSO4 gives FeSO4 plus Cu. This activity shows that iron is more reactive than copper, so iron can displace copper from its solution of copper sulfate. Let us see one more example. A test tube is half filled with silver nitrate solution and a copper coil is dipped into it. After some time, we will notice that the copper coil gets coated with silver while the solution turns blue. This shows that copper is chemically more reactive than silver. We have the equation 2AgNO3 plus Cu gives 2Ag plus CuNO3 twice. Due to the formation of copper nitrate, the solution turns blue. Colorless solution of silver nitrate turns blue due to the formation of copper nitrate. Here, copper being more reactive than silver displaces silver from silver nitrate. So it shows that copper is more reactive than silver. Now we learned that zinc is more reactive than copper, iron is more reactive than copper, copper is more reactive than silver. Displacement reactions help us to determine which metal is more active and which one is less active. On the basis of the rate of the reaction of metals with oxygen, water and dilute acids, metals have been arranged in the decreasing order of their chemical reactivity. This series is known as reactivity series. The arrangement of metals in a series in descending order of their reactivity is known as the metal reactivity series. Metals are arranged in the decreasing order of their chemical reactivity. This list is known as the metal reactivity series or metal activity series. Among the commonly known metals, the most active metal, potassium, is kept at the top of the list, and the least active metal, platinum, is at the bottom of the list. So, in the reactivity series of metals, the most active metal, potassium, is kept at the top of the series, and the least active metal, platinum, is at the bottom of the series. Here is the metal activity series. The most reactive metal, potassium, is at the top and the least reactive metal, platinum, is at the bottom of the list. In between, you can see metals like sodium, calcium, magnesium, aluminium, zinc, iron, lead, and a non-metal, hydrogen, is also placed in the reactivity series of metals. Below hydrogen, we can see copper, mercury, silver, gold and platinum. Why hydrogen is included in the activity series of metals? Hydrogen is a non-metal, we all know it. Hydrogen is included in the activity series because, like metals, it loses an electron and becomes positively charged ion in most of the chemical reactions. Moreover, this hydrogen adds a borderline between the most reactive metals and least reactive metals. Metals above hydrogen are more reactive and metals below hydrogen are less reactive. And metals above hydrogen in the activity series can displace hydrogen from acids. Today we learned about displacement reactions and metal activity series. It's time to wind up. Thank you.